Okay, we are doing a little introduction to solubility equilibrium. So this is the equilibrium of a salt dissolved in water. KSP, a new K, all about dissolution of salt. So we have the solid and we have its aqueous forms. This becomes a little more interesting because quite often your coefficients are not just one. You have your KSP, remember aqueuses are present, solids are not. This is based on ratios of each product. KSPs are often small, sometimes ridiculously small. Remember, small k means little products, much more reactants. We would often say something like calcium phosphate is insoluble. However, it is soluble, but to a very minute amount. Now, the equilibrium solubility is not molar solubility. It is related to the amount of ions that break up in solution. A little more work to determine that. We use the same idea. We can be given molar solubility to find the KSP. So let's take a look. We have an ice table or rice table, whichever you prefer. Again, we have no calcium ions or phosphate ions to start. The change, we have 3, we have 2, equilibrium 3 and 2. So often we don't even start off with any. That's not always going to be the case though, as we'll see in the next unit. So we have our amounts here. S is the idea of the solubility amount. We have however much is dissolving here by moles, we have 3 moles here and 2 moles here. So that's why we have this S here, not X. S for solubility. So the 3 moles cubed, 2 moles squared. We get this value here, do a little math to get 108 of the solubility to the 5th power. Again, solve for our math. And so the solubility of calcium phosphate is 2.63 times 10 to the negative 6 moles per liter. We often just call this solubility, but I know on the test and in the AP we'll refer to it as molar solubility. So keep that in mind, okay? So 2.63 moles of this will dissolve, giving me 3 times that value here, 2 times that value here. Those are going to be equal to our KSP. That's how we're able to solve for solubility in this case. Now, KSP and relative solubility, which is more soluble? So this is based on a comparison between two objects. Okay, this comes up quite a bit. Which one's more soluble than this one? Now, here's the key. You can't compare the KSP and molar solubility if the dissociation ratio is not the same. Let's for example, this one produces 3 ions, 1 magnesium, 2 hydroxides, compared to this one, which has 1 iron and 1 carbonate. So the KSPs are very close. And if you looked at KSP, you might think this one is less soluble or more soluble because it has a lower negative exponent. Kind of the way to think about it. But we see that this one actually has a higher solubility overall. Again, we would do the math behind it, okay? But if they have the same amount of ions present, you can compare, okay? So I see this one is smaller. That means this one is smaller, right? And again, I had to wrap my head around the negative exponents as well. A lower negative exponent means larger. So larger, larger. So we can compare which one dissolves more if they can dissolve the same amount of ions when they do. If they don't, we got to do the math. You can be easily fooled. Let's look at a couple calculations of this in action. So we've got an idea of barium chromate has a solubility. This is what you normally find online, grams per liter. Calculate the solubility product of barium chromate. Rice table again, we don't do anything with the solid. I can see that this is a 1-to-1 ratio, so I got X and X. Now I need molar solubility. This is mass. Mass to moles. This is my molar solubility. Often, we don't write it as a molarity, but that's what it is. Now my KSP is this times this, X squared. So I square it, and this is my KSP. You see it would work the same way, that if I had this as my KSP, is my X squared, square root both, This is my molar solubility. A different example, silver thiocyanate, very low KSP value, calculate the solubility in moles per liter, what we call molar solubility. Again, rice table, very simplistic. I got my KSP, x squared, square root of that. I have my molar solubility. Your molar solubility, keep in mind, is going to be higher than your KSP. Okay? It's always going to be higher because you're doing some squared or doing some other funky stuff to it, to where this is only going to get smaller. Okay? All right, so you can see these are pretty brief, pretty simple. An easy way to get kids flummoxed on this exam is just by thinking that this is too easy. Just make sure you run through an ICE table to make sure you're comfortable with it, seeing it to work. Again, this takes a lot less time than you think. Come in with your questions and I'll take care. Bye-bye.